The last thing we're going to check is shear. In determining shear, we are going to figure out what our V force or our shear force is. And what that is our reactions. We're going to multiply that by 1.5, and then we're going to divide that by the area of our selected member. So in this example here, we have our 10-foot span with 100 pounds uniform load that we've done from the other two examples, and we have a reaction of 500 pounds on both sides. So that reaction is V. And what we would do if it was not equal, we would pick which one is the worst case scenario and solve for that, because that's going to be the worst example. And we basically just plug this into the formula. So we take the 1.5 V, and then we want to take the area of our member. And what we had come up with for the other two, for deflection and for section modulus, was a 2x10 southern pine. So we figure out that area. A 2x10 is 1.5 inches by 9.25 inches high. If we multiply that together, that's our area. So that's 13.875 square inches. So we plug that in. So we take 1.5 times 500 divided by 13.875. And that gives us a FV max, or a shear max, of 54.05. So that's the amount of shear that is placed on this beam because of this load. Now, and that's also a per square inch number. Now we go back to our design charts, and in this example here, this is a southern pine. And if we look at the box that I have highlighted here, the red box, the shear parallel to grain, the FV, is 175. So in this example here, a number 2, a number 1, select structural, dense structural, all those, it all is the same per square inch shear factor, and that is 175. So to test this, we have our FV max has to be less than the shear parallel to grain value of that FV. So in this case here, 54 is less than 175, therefore this beam would be okay.